All right, good afternoon, everyone. I'm Severio. I'm on the organization working group for the conference. And the next presentation is on sizing heating equipment. And we have Chris Sagan as as the presenter. He's actually on the working group as well. He's a project officer for Mushkegowuk Council, which works with 7 First Nation communities in Northern Ontario. Those communities are Attawapiskat, Kasheshawan, Fort Albany, Moose Cree, Taikwa, Tagamo, Chapleau Cree, and Missinabee Cree First Nation. Sorry if the pronunciation is a little off. Chris has graduated from Laurentian University with a bachelor's degree in mechanical engineering in April 2014 and has been working with Mushkegowuk since January 2015. One of Chris's roles with Mushkegowuk Council is to provide code compliance inspections under CMHC Section 95 for his member communities. Chris is currently designated building code qualified in housing under the Ontario Building Officials Association since January 2016. Chris is eager to share his knowledge regarding the Ontario Building Code to improve housing in First Nation communities. Okay, here's Chris.
Hey everybody, how's everyone doing? Everyone hear me in the back? Thumbs up. Yeah, there you go. Perfect. Awesome. So as Severio mentioned, my name is Christopher Sege with Mushkegowuk Council. I've been with them for almost 8 years now. So over the past 8 years, I took a lot of training. I started out pretty green at the organization. So I relied heavily on these training organizations like OBOA, HRI, just to expand my knowledge. And one of the courses I took was heating and cooling calculations through HRI. So I just have some questions here for the audience that better gauge on what sort of individuals we have here, what sort of equipment they use, what fuel sources are used. So I'll just go through each question, and for each possible answer, maybe just raise your hands and we'll go like that. So my first question is, what kind of equipment or appliance does your community primarily heat your homes? So who uses baseboard heaters here? Okay, we got some in the front, some in the back. Awesome. So forced air furnaces. Okay, a lot more. Great. Boilers. Just like, yeah, a couple. Okay, awesome. Any other appliances that I might have missed? That's more or less it. Okay. Wood stoves. Okay. And for fuel sources, what do you primarily use? Do you use gas, propane, or natural gas? Raise your hand. Okay. Electricity? Plenty of hands. Okay. Other? Oil? Anyone use oil? Wood? Okay. All right. A little bit of both. And one more question. So how does your HVAC technician size heating equipment? So for the first item here, new construction, your HVAC tech will use his previous experience with new construction projects. So in this case here, he'll say, okay, this is my 1,000 square foot home. Based off like current energy efficiency codes, I will put in a furnace that's so big. So for example, I'll put in a 40,000 BTU furnace. Would you say that your technicians would do that approach for new construction? Any hands? Okay, not too many. All right. So how about for existing construction? So if you're replacing a furnace, for example, he just replaces the furnace with a new one of the same capacity. So if you previously had a furnace that was 50,000 BTU, was installed in year 2000, and it's 2022 today, has to be replaced, does he put in the same size furnace? Does he go smaller? Does he go larger? Would anybody have a better idea about that? Smaller? Okay. All right. And another option here is getting an actual designer to perform a heat loss and heat gain calculation for each specific home. Does anyone see those? Usually you see them in early in the design process, but also you could do it for existing housing. Does anyone have experience with heat loss and heat gain calculations? It's usually like an 8-page document, a bunch of numbers, and it probably doesn't make much sense for a lot of people. I don't see too many hands. Oh, Derek. We don't require it, but if we have it, we'll look at it. But we'll talk more about that later on in the session. So who's not sure about these items? Like I'm sure a lot of people don't know what a heat loss and heat gain calculation is. They may not work directly with the HVAC technician. So it's more or less what you see, what you get. Are you happy with it? Yes or no? That type of thing. So some learning objectives for this session. So I just want to introduce delegates to the CSA standard F280, determine the required capacity of residential space heating and cooling appliances. So primarily for this session, we'll talk about heating. The standard talks about cooling too, but I know a lot of our First Nation communities, we don't really deal with cooling too much, so we won't be discussing that today. And we want to understand reasons why a heat loss calculation may be a good design practice to adopt for your community. So I know a lot of communities, as Derek mentioned, maybe a community doesn't ask for it, an owner doesn't ask for it, your general contractor won't supply it. So it's really, or your inspector won't ask for it either. So it might be like a missing piece in the design process that you could adopt for your community. And we want to develop knowledge of key factors that affect the heat loss calculation. So those are design conditions, indoor and outdoor, R value of your building assemblies, the efficiencies of your mechanical equipment, so your furnaces and your HRV, and air leakage. So just a disclaimer here. So we're not going to, I'm not going to teach the calculations themselves, because usually like what I'm discussing today, it's usually like a 4-day course. So I'm going to try to sum it up in 40 minutes and just give you guys a sneak peek of everything. And we'll only be discussing residential units, so commercial units won't be discussed at all. That's a different topic. So just residential, Part 9 housing, group C. So restaurants, churches, whatever it may be, that's not included. So I want to say the word equipment and appliance slots. They're the same term. I'll use them interchangeably. Same for sizing and capacity. I'll use those interchangeably as well. And those both could be expressed in watts or BTU. The use of wood stoves will not be discussed. So building codes require the use of appliances, commonly gas or electric. That could be oil as well. To primarily heat a home. So a wood stove, it can be used as a secondary heat source for your home, but it's not counted towards the BTU or watt requirements required for your home or individual rooms. So why perform a heat loss and heat gain calculation? So it's the basis for fully designing your heating system. So you can't do proper duct design, you can't do proper radiant heating loop design and proper commissioning of your heating system without doing a heat loss and calculation. So also it could improve comfort. So it's really possible to heat and even cool a home. So there's minimal difference in temperature throughout the home when you combine proper ducting, radiant heat design, and commissioning. So a common problem with that is, say your second-story house. In the summer, I know for a lot of people, it's usually a lot warmer on your second story than it is your main floor. So that's an issue with your duct design. You can actually design that the temperature at the second floor is the same as the first floor, which is the same as your basement. So we really want to try to improve comfort. And another one in here for comfort is your heating equipment cycles less frequently for proper selective system. So usually with an oversized system, your furnace will start up. If it's grossly oversized, it'll run maybe, let's say 5 minutes. So generally you want to keep our equipment sized more appropriately and run for longer cycles to improve the efficiency. So another item here is that it ensures the equipment is unnecessarily oversized, as I mentioned, with it could contribute to higher operating costs and possible higher equipment costs. And it ensures the equipment isn't undersized. So when it's minus 35 and wherever you live in the winter, that's heating system is capable of producing enough enough heat for your home, and it's not getting cold, and it's actually getting warmer. So another item here is it could be required by your building code. So I took just a few screenshots from the Ontario Building Code and the National Building Code of Canada. So they more or less say the same thing. So here, just the screen on the left, or the screenshot on the left. So heating, ventilation, air conditioning systems, including related mechanical refrigeration systems, shall be designed, conducted, and installed to good equipment practice, engineering practice, appropriate to the circumstances, and it gives possible solutions for that. So the screenshot on the right more or less says the same thing. It all comes down to good engineering practices and what those actually are. So just part B on the screenshot on the left, it actually states the standard CSA F280 as a suitable method. So your building official may one second. Your building official may require it, a heat loss and heat gain calculation. He may not. Your community may require it, may not. But it all comes down, I guess, to the owner and then your inspector on what's required for your housing and your projects. I mean, we'll just take questions at the end if you don't mind. Got quite a bit to go through, so just write down your questions along we go, and we'll get to as many as we can. So as I mentioned, the CSA standard F280 is commonly used, and that's just a screenshot of what the front page looks like. So how is the calculation performed? We generally use hand calculations, utilizing the standard. And that's a primary method in Canada. There's other methods you could use. So just going back here, there's mention of ASHRAE, the American Society of Heating, Refrigeration, Air Conditioning Engineers. They also have a general guideline on how to size your equipment. But I've never seen it with my communities. I heard about it, but it's not generally used too often. So we'll just focus on the CSA standard. It's more common for us. So the standard provides more of the methodology for completing the calculations, while HRI, the Heating, Refrigeration, Air Conditioning Institute worksheets, provides a way to organize and complete the calculation on paper using their spreadsheets. You'll see in the standard, it's several pages, but it doesn't give you like a clear indication how to organize all your work, because there's so many calculations involved. So that's where you rely on those worksheets from HRI. They compile it all in a sometimes 8-page document that's more user-friendly to look at and visualize, find the information that you need. And also, you could use specialized computer software. The most common one that I've seen is RightSuite. So instead of doing it by hand, you got a computer program. So if you're a bit rusty with math, you have big fingers with a calculator, RightSuite's the way to go. Because if you make any mistake in hand calculation, it's really hard to go back. Sometimes at the very beginning to make adjustments. So one mistake early will throw off the entire calculation at the end, sometimes small, sometimes big. Okay, so minimum requirements for when sizing heating equipment. So the total heating output capacity of all heating systems installed in a building should not be less than 100% of the total building heat loss. So an example for that, let's see, your furnace, for example, it must meet your minimum capacity to meet the needs of the entire home. And in contrast, or to go along with that, there's another statement here. The combined heating delivery of your heating system that serve a room or space shall not be less than 100% of each of the heat space loss. So an example for this, say if you're looking at a bedroom, your individual bedroom will have a very specific heat loss. And if you're using a baseboard, for example, that has to be sized appropriately for that specific room. So some important factors that affect sizing of heating equipment, as I mentioned earlier, so the location, your outdoor design temperature, comfort requirements, that leads to more indoor design temperature. The square footage of your home and the size of each individual room will all affect the capacity required for your heating appliance. Your building assembly materials, your foundation heat loss, that's typically your foundation in ground contact with soil. Air leakage, that's a big thing. Even in the standard, it even says directly that air leakage in your home could result in 40% of your heat loss cumulative. And there's ventilation, so your HRVs. I'll talk about more of these right now. So for outdoor design temperatures, we primarily look at the winter design temperatures, and is based on a 10-year average. It's the lowest sustained temperature that might be expected in normal winter conditions. The coldest month is January, and 2.5% of the time in January, the outdoor temperature may rise above the design temperature, but usually for only a short time. And I know a few years back, there was that polar vortex in Timmins, Thunder Bay. So it was a very cold period of time, but again, it was short-lived. So we want to try to size our appliance so when that polar vortex does come, we'll be prepared and our house will be warm enough. So when actual temperatures go beyond the design temperature and there is no excess capacity in the equipment, thermal momentum will carry the building through these conditions for a short period or a small degradation of comfort conditions can be expected. So just going back when it's say minus 35 out there, maybe your heating equipment can't keep up in a way. Maybe it can't reach 22 degrees in your house, but maybe 21. So it's a slight loss in comfort there. Most people are comfortable about 22 degrees Celsius, but 21, you're still warm. You're not freezing. So usually in your building codes, you'll see something like this for climatic data. So for Thunder Bay, for example, just the red square. I found that in the building code, and I could find the design temperature for the first Thunder Bay in January for the 2.5%, and that's minus 31 degrees Celsius. So you could do this for any location. It could be Thunder Bay, if you're somewhere in the Yukon, BC, every location should be shown. If your location isn't shown, there's usually somewhere close where you'll have this data to collect and look at. So this leads to indoor design temperatures. So generally designers need a baseline indoor temperature to form the basis of their calculation, which provides a level of comfort for the average person. So the CSA standard F280, it gives these minimum indoor design temperatures. So generally all locations in your home, you'll want it to be designed at 22 degrees Celsius. That'll provide the optimal, I would say, comfort for the average person. While your heated crawl space, that decreases to 15 degrees Celsius, and unfinished basements is 18 degrees Celsius. That's the design basis for the calculations. So the minimums provided can be increased based off comfort needs of the community tenants. So when a designer is doing his calculation, he's just going to assume, okay, let's say for myself, I'm comfortable at 22 degrees Celsius. So I'll base my indoor design temperature on that for my main level, for example. But let's say you have an elder or someone else that prefers it to be warmer. They want to see it bump it to 23 degrees, 24 degrees. You could relay that information to the designer, and it could be used for the calculation. It's very important to relay that to the designer, because if it's too late in the process, then it's more or less a lost opportunity at that time, just for the calculation purposes. So another factor with which affects the heat loss is your house size and layout. So it's whenever a designer or a technician will come or to do a heat loss calculation, they need a design of your home. They need the layout, they need the measurements, they need to know your size of your windows, your doors, of every single room. They need this information. Without it, they can't perform the heat loss calculation. So generally, it's good to have like a professionally developed drawing from a designer. That's the best way. But sometimes, say for an existing house, if it's a bit older, you don't have the drawing, you could actually go there and take your own field measurements and work from there. That's perfectly acceptable too. And even more so when field measurements are taken, the technician will generally make assumptions, because he doesn't necessarily know how thick your OSB sheathing is. He'll make assumptions for the time. So generally, as I mentioned, so the house size and layout, that really affects your capacity of your furnace or whatever equipment you choose to be selected. Your building envelope assemblies. So as you all know, there's various assemblies involved with the home. There's your above grade walls, walls below grades, your foundation walls, you have ceilings, doors, windows, skylights, your header and rim joists, floors on soil, exposed floors. All these assemblies have to be looked at when performing a calculation. And it's all the information regarding R values, thicknesses, that's all noted best to the designer's ability. So just to further expand on building assemblies, we talk about nominal R value of assemblies a lot. So the nominal R value of assembly are the values listed for the insulation component of the assembly. So say if your bad insulation, say R22, you clearly see that on the bag, so we know that. But other materials in your wall, in your assemblies, sometimes it's harder to determine. Let's say my example here is vinyl siding. Who knows the R value of vinyl siding? Probably no one. So in the CSA standard and HRAI training, I should give you like a table, which we'll show a bit later, and it'll give you a better idea on how to assign R values for your building materials. So again, it's the designer's discretion on what R values to assign materials if they are unknown for assembly. A conservative or aggressive R value could be assigned. A good example for this is your windows. If you look at a window, you might be able to tell certain characteristics about the window. Like, hey, does my window open? Is it a slider? Is it fixed? Is it aluminum framed? Is it vinyl framed? Some basic information like that could be it could be easily identified. But other areas like the spacing of individual panes of glass, that's a lot harder to determine by just a field measurement. So your designer will essentially guesstimate on what the R or what that specific window is, what it's characterized as. So I have a few examples here just to go over the previous points I mentioned. So the R value materials, so your vinyl siding. So this is an example of a chart that will be provided in the CSA standard. And if you take HRI training, you'll have this chart as well. So siding there, might be hard to see in the back. It's a little bit blurry for me and I'm up close, but it's highlighted in yellow, and you can see siding, vinyl hollow back, the R value is 0.62. And we could use that or your designer would use that for design purposes. So other materials be in there as well. So if you have a concrete foundation wall, it's 8 inches thick, it'll actually show you what the per inch basis of R value that concrete wall is. I don't have it displayed here, but it might say it's a 0.1 R value per inch. We have 8 inches, so 8 times 0.1, 0.8. So we'll have an idea what R values R for every material within an assembly. So again, windows, as I mentioned before, this is another table that will be that's provided in the CSA standard and HRI manual, training manuals. So there's a lot of numbers here. It could be very difficult to go over the chart. If you just look at the bottom there, the bottom row, we could say, okay, the frame of the material is operable, and it's a vinyl window. From there, you could just go across the table if you have insulated spacers, metal spacers, and if you know if a coating is applied to your glazing, you just work your way across the table and assign an R value. So again, this is very subjective. It's based, the designer will make his best guesstimation on what window is actually installed in a house for a field measurement. Sometimes if you get a new construction, you could get all like very specific information from the window manufacturer, and you can use that information or that assigned R value for a more I guess specific R value for the calculation. So this leads to effective R values. So generally with heat loss and heat gain calculations, once you identify your building assembly and all your materials, we want to know the effective R value of that entire assembly. And for example here, an exterior wall above grade will have plenty different materials within that assembly. So you have your drywall, you'll have your insulation, you'll have your lumber, your OSB sheathing, siding, any air spaces, that kind of stuff. So generally, we want to add all that up to find our effective R value from assembly. And you do that for all your assemblies. So just going back to, let's say, how does framing affect a wall's effective R value? As you know, for the example here, if we're assuming a 16-inch off-center spacing for our wood studs for our walls, and let's say our R value here is R19. We go across the table, we'll get an RSI value of 2.36. That's equivalent to R value of 13.4. So just looking at that alone, we know our insulating component in that stud wall, it's R19, but due to the wood framing, which has a lot less R value and takes up that space in that assembly, it reduces the effective R value within that space. So this is just another example here of calculating effective R values. So here's all the individual components, and we pretty much just add them up. It might be difficult to see. So we add up all the R values for every material within the assembly to get an effective R value, and that's used for our heat loss calculation. Foundation heat loss. So for rooms or spaces with floors or soil or foundation walls at level of exterior grades, so slab on grade construction, we must determine the heat loss. So for there, we use a software for the calculation. There's no hand calculation. When you purchase the standard, they'll give you an Excel sheet, and you can use that for estimating your heat loss. So here's an example here regarding that spreadsheet I talked about. So you'll put in your basic information. So the one on the left, it's Ontario. I selected Windsor. I made some assumptions regarding the site. So your soil conductivity, water table. You more or less just fill in information, and you see right there, it says installation configuration. If you click on that, you could really hone in on what your installation components within that assembly actually is, and you can assign an R value. So primarily in the end, you'll get a heating load based off for your foundation. And the screenshot on the left was for Windsor. I just did that quick calculation. I got a heating load of 2,461. But in contrast, let's say in the Yukon and Whitehorse, the same exact configuration, insulation, size, soil conductivity, all that, same thing, just location is different. The heating load went up to 3,360. So it really depends on where you are in the country. If you're in Southern Ontario, it's going to be lower. If you're in colder climates like the Yukon, the load will be higher. Another factor here is air leakage. So air leakage is the uncontrolled exchange of air between the interior and exterior environments through unintentional openings in a building envelope. So we know this as air tightness. You probably heard that term, or air exchanges per hour. And heat loss to air leakage is calculated by software again. We can't do it by hand. We have to rely on the software. And it's just very, just many factors that's dependent on it, such as the location, like local shielding, the configuration of the building, that kind of stuff. And at the end of well, I'll just show you, it might be easier. Here's a sample of the spreadsheet for air leakage. So again, we'll put in our information. So here I just used Prince Edward Island and Charlottetown, and identified local shielding. So local shielding, it's like, okay, is my house beside the ocean, or are we surrounded by high trees? Are we in the middle of a city with some tall infrastructure around that could like essentially block wind in a way? And yeah, we fill in our building configuration and work down the spreadsheet. And a key item here is your air leakage. So you'll see here that for air tightness type, for this configuration, I chose energy tight. So that equates to 1.5 air exchanges per hour. But that could change depending on your house. So for new construction, we should aim for energy tight construction. But for older construction, let's say if I'm doing a heat loss calculation for a house built in 1970s, the standard of construction was different back then. The housing was a lot more loose, more air leakage. So that value would be increased to 4.5, around there. Also, we could include custom data. So for example, if we built a house last year and we did a blower door testing, we calculated the air exchanges per hour of that house, and we get a value. Let's say it's 1, and this year we're planning to build the same house. The construction should be the same. The quality build should be the same. So we could input 1 for custom data. So in the end, we'll get a factor. So in this case, we got a factor of 0.134. And again, this factor is used in further calculations, but we won't talk about those right now. And we'll just leave it at the higher the factor, the more air leakage is occurred for that build. And ventilation. So if an HRV is used in your home, most new construction, you'll see HRV installed. The heat loss is primarily determined by the efficiency of the unit. The PVC ventilation rates, design temp differences for heating, and if there's no HRV use, there is no heat loss to the ventilation. So just a quick summary here on the factors affecting appliance capacity. So as I mentioned, the lower outdoor temperature increases capacity. So the colder you are, the warmer you got to heat your home. There's a bigger temperature difference there between your indoor design temperature. So it takes a lot more capacity for your system. And your higher indoor design temperature. So as I was saying, our standard goes by 22 degrees Celsius for like your bedroom, for example. But if you want the higher, it'll affect our heating requirements, so it increases the capacity of your appliance. Lower insulation values of building assemblies increase the capacity. So if you have an old house, not much insulation, you're gonna need a lot larger furnace to for that unit. Larger homes increase the capacity. So a 3,000 square foot home, you'll need a larger furnace compared to a 1,000 square foot home. Higher air leakage from your home increase the capacity. So essentially, a lot of your heat loss, it gets lost through, like, say, pinholes, some gaps in some sealing methods in your home. So yeah, more air leakage causes increased capacity for your equipment. And the use of HRVs with lower efficiencies will increase capacity as well. So what to do after calculation is complete? After the calculation is complete, data is compiled to determine the heat loss per room. And the data is further added up to determine the heat loss for the entire unit. So using this data, we could size an appliance for an individual room or the entire unit. So we could size a furnace that's 50,000 BTU for the entire house, or we could assign let's say a 1 kilowatts electric baseboard for a certain room in your home. So an important consideration for gas appliances is the output versus input capacity of the appliance. So we always select equipment based off its output capacity. This is due to the energy efficiency of the appliance. And I'll talk more about this shortly, but yeah, the output capacity is generally used for selection. And so quick note here, electric appliances are 100% efficient. And when sizing equipment, it is important that it's sized to minimum value provided heat loss calculation. So we always want to be above the minimum requirement. So for example, here, if we do our entire calculation and we determine the heat loss for the home is 34,222 BTU, we got to meet that minimum. So we got to size an appliance that's larger. We can't buy an appliance that's at that specific BTU. So we know we need to go a bit higher. So that could be like a 35,000 or 40,000 BTU appliance. So we definitely have to be larger, but we don't want to be, I guess, too large either. If we need a 34,000 BTU roughly, we don't want to put in a 60,000, 80,000, 100,000 BTU furnace. It's just way over capacity. So we generally just want to be over, but we also don't want to be under. So a 30,000 BTU furnace, for example, it wouldn't be appropriate for the unit. And another important item here is it's very important to determine the type of appliance that you're planning to use for heat your home. So a furnace can heat your entire house with proper ducting, while a baseboard heater can heat individual rooms. So different communities may have different practices. So you may use a furnace with ducting. You may use electric baseboard heaters. It's good to provide that information to your designer, because ultimately, once we have our heat loss calculation, we want to select equipment for your HVAC technician. He'll select the equipment. Your engineer, someone will identify a specific furnace to put in. So it's good to provide that information. I've seen before that some information isn't provided along the way to your designer. He makes assumptions. So we have one case, a community primarily uses electric baseboard heaters, so that would be their primary source of heating. But the designer, he assumed it was like a furnace with natural gas, and there was no natural gas in the community. So just relaying that information to anyone who's involved in the design process is heavily beneficial. So I know before I mentioned about these HRI worksheets, this is an example of the first 2 pages, and it more or less goes through all like the stuff that I talked about previously. These worksheets, they could be found online, they're free to use, but they could be intimidating to actually fill in and fill in correctly. This is just 2 pages out of 8, so I'm just going to focus on on primarily the second page. So usually when you get a heat loss calculation, you'll get your heat loss for each individual room and on each level, and it'll give you a value in BTU or watts. And as I mentioned before, all of them for your home will be added up to determine the heat loss for that entire unit. Essentially, from there you can select equipment. So input versus output capacity. Sometimes the output capacity of an appliance may not be located on the appliance's identification plate. Instead, the input capacity is shown along with the efficiency of the unit. As I mentioned before, when we select equipment, we got to make sure we're above that minimum that's identified by heat loss calculation. So if we don't know information, we can always check the manufacturer's specifications in their manual, but also we could determine on the site. So a lot of times the identification plate, it'll show the input capacity and efficiency. So from there we could calculate our output capacity. So this example here, our furnace, it's a 50,000 BTU furnace. The efficiency is 95%. So we just multiply it out, and the output capacity is 47,500. So we could do that in the field. As I mentioned before, the efficiency of electric equipment is 100%. So the input capacity is the same as the output, essentially. And usually electric appliances like baseboards, we see it expressed in watts or kilowatts. So where to go from here? So if you're planning like future housing projects, consider opting to complete a heat loss and heat gain calculation. I know I talked more about heat loss for this session, but usually the heat loss and heat gain calculation, it's done the same time. So for the heat gain calculation, we'll be sizing our air conditioning unit. Well, heat loss, we're sizing our heating equipment. So furthermore, we could consider adopting duct designs and radiant loop designs, because they go hand in hand, as I mentioned previously. Once you do your heat loss calculation, that's just step one. And from there, you could really fine tune your duct designs and radiant loop designs. That also leads to commissioning too. As I know for a lot of like housing units, or even my house, for example, my bathroom, I had a 5-inch duct supply. My furnace was used with natural gas, and the 5-inch duct was way too much. Supplying way too much heat to my bathroom. Just a small space, so 5-inch was a lot. I reduced it to 4-inch, and yeah, I have no problems with that. So that's just a commissioning aspect, because even in your commissioning, I know a lot of communities don't do this, but you can really fine tune your how much CFM or liters per second of air is needed for an individual room. You could really fine tune that. Say, okay, my bathroom, I could select 72. The HVAC technician could really optimize like 72 CFM for that specific room. Just adjust a damper for by the boots of the duct. And so for your future projects, so as an owner, bare minimum, you could probably check to ensure that individuals completing your heat loss calculation is certified, because we want certified individuals to complete these calculations. So you could actually check online. If you go on HRAI's website, you can see who took the training, who's certified, and as an owner, you could take that approach to make sure the individuals are qualified doing those calculations. Or you could pass along to your tribal council or another technical unit if you feel that way. And if you're interested more in the standard and completing the calculation on your own, you could take the HRI training. As I mentioned before, it's a 4-day course, and you can really expand your knowledge if you're curious. And if you really feel like completing your own calculations at your First Nation or tribal council, you could take the HRI training, and you could further training for Right Suite software. So as I mentioned before, the computer-based software for calculations. It's a lot quicker. And if you make a mistake, it's a lot easier to make adjustments and without redoing the calculations compared to hand, because as I mentioned before, hand calculations, once you mistake, you got to go back and make adjustments. But computer-based software, it could be expensive for some communities. It's like $1,500 to $2,000 for the software. So that may be beneficial, may not be. It's really up to the community and your technical provider. And yeah, that's it in a nutshell. It's usually a 4-day course, and hopefully I summarize it here in I don't know, 30 minutes or whatever it is. And yeah, I'll take some questions. A guy in the back.
Sure, we're a bit short on time, so just a couple of questions, if that's okay. The next session has just started next door. It's the success stories. Who had the question? Oh, Scott.
How often, how important is it to have your cleaning ducts, your furnace ducts cleaned?
Usually every couple of years, you could get an HVAC technician and have your ducts cleaned. It's really dependent though. You could usually, like say if your ductwork is accessible in your crawl space or basement, a lot of times your ductwork is exposed. If you really want to, you could take a look and peek, see if there's a lot of dust accumulation, but every couple of years you could have it cleaned out. Because really all that dust is accumulating in your ductwork, right? And say your blower is blowing all that air, and it's really could affect your indoor air quality. So you're breathing in all that dust, and if you have like any children or any sensitive individuals, that could affect them as well. So it's good to have it done often, but again, everything comes at a cost. So you really gotta work within your budgets in a way.
When you're doing the calculation of components of a wall, I'm surprised they had exterior air film as part of the R value. That's
Yeah.
on the outside of the vinyl siding.
Yeah.
Why is it included? And is it like a minimal thickness of like 1/2 inch, assume like dead airspace, or why is it included if it's exterior?
Well, from
air?
my understanding, there's air films on the interior of assembly and the exterior. It's just a small value, but this air film, it provides an insulation value. Why the outside? Because the airflow currents from the outside, similar to the inside, there's a small current of air that's running alongside that, the inside and outside of your assembly, and that creates a small insulation value, if that answers your question. I can't go too much into the science. I'm not a building scientist, but that's from my understanding.
Okay, last question.
I have one question. As an inspector, can we perform testing for HRB balance?
Can you repeat that?
As a housing inspector, can we perform testing for HRB balance?
So as a housing inspector, what could we do? Or
Yeah, we could do that. If you can, do you need special equipment for testing?
oh, so as a housing inspector, if you want to do your own calculation,
No, not calculation, just the contractor install the HRV in the house, right?
okay.
So I want to
Okay.
test the HRB balance.
Okay, so as a housing inspector,
Yeah.
if you have your heat loss calculation, you could say, okay, the calculation tells me I should have a minimum capacity of, say, 33,000 BTU for our furnace. As an inspector, you could go to your appliance. There should be a label there that's either says your input or output capacity of that appliance, and you could check to make sure that it's at least higher than that minimum value. So you more or less just verify. You have your calculation, it gives you your heat loss value. As the inspector, go to the appliance, check the label, make sure it's higher, and check it off essentially that it has that minimum capacity.
Okay, thank you, Chris. On behalf of the working group, I'd like to thank you for your presentation.
thanks.
And also, as I mentioned, about 10 minutes ago, I believe, the session next door began, and it's on the, okay, so they're waiting a few minutes. So it's success stories. Grab yourself some coffee out there. There should be coffee, and then we'll be starting that shortly. Thank you. Oh, and don't forget to fill out your feedback there on the forms or on the app, please. Thank you.
I was in the zone, man.
So, yeah, no, it's good.
Okay, all right.